Well, we have covered a good distance for us to start talking about blockchain, which is what this course is all about. But it is important to remember all the points we have discussed in earlier sessions on evolution of web, database structures, and challenges around distributed systems. All these technologies and concepts are an integral part of any blockchain application. Let us now see what some industry and technology leaders are saying about blockchain. Blockchain is what the internet should have been. Blockchain is the internet of value. Blockchain drives a shift in power from the center to the edges of the network. Time to look into the formal definition of blockchain. Blockchains are decentralized databases and a peer-to-peer network that store a registry of transactions. The above definition has three distinct aspects to it, which are decentralized databases, peer-to-peer network, and a registry of transactions. Summarizing the above, blockchain is a decentralized database where data is distributed among participants, and a peer-to-peer network where participating systems maintain the integrity of the network that stores a registry of transactions, a ledger containing transaction data. Instead of using an intermediary, it uses a consensus mechanism as a basis of trust, accountability, and transparency for all participants in the network. We will discuss what consensus is in further sessions. And why is it called blockchain? All ledger transactions are recorded using a block-based protocol. That is, each set of transaction information is stored in a block. As the new blocks are formed, every block contains a reference to the previous block, thus creating a chain of blocks, called as the blockchain. These blocks are linked together by cryptography. The concept of a block and cryptography will be explained in details in later segments. To understand blockchain technology, it is necessary to understand the underlying components of its ecosystem and the function of each component. The first, digital ledger. The digital ledger is essentially a database that is continually updated with all transactions on the blockchain in cryptographically linked blocks. Network participants, also called nodes. These are personal computers which are connected with each other and have the blockchain stored on their respective hard drives. Connectivity to the blockchain is done via an internet connection, which allows the nodes to perform consensus on the transactions. Their primary role is to support the network by discovering and maintaining connections to peers and validating and propagating transactions in some cases. Although all nodes have equal rights and equal privileges in the blockchain, certain nodes have different roles in the way they support the network. Nodes are broadly classified into two types. One, full nodes. Full nodes maintain a complete and a latest updated copy of the blockchain. They autonomously verify any transaction without referring to any external sources. Lightweight nodes. These nodes maintain only a subset of the blockchain and verify transactions. Mining nodes. Mining nodes compete to create new blocks on the basis of consensus algorithm. Mining nodes, often called as miners, can be a full nodes, that means maintaining a full copy of the blockchain, or they can be lightweight nodes too. Consensus mechanism. This is a mathematical algorithm that determines the ordering of transactions in an environment that ensures the parties follow the protocol and prevent unethical practices. It helps maintain the single state of the transactions or a global state of the transaction. Validity rule. A standard set of rules of the network. For example, what transactions are considered valid, or how the ledger gets updated. Digital assets. A digital asset is the transaction item on the blockchain being transacted. This asset can be any unit of the several blockchains. Popular examples of digital asset include Bitcoin in the Bitcoin or Ether in Ethereum. Let us now put in contrast the centralized versus decentralized systems, highlighting the blockchain advantages. Starting with the definition, centralized systems are the ones where decision-making capability rests in the hands of one central or controlling authority, meaning decisions on the data manipulation or management, acting on the instructions given, or even the decisions like what kind of services are rendered are left in the hands of a central authority. Decentralized systems, on the other hand, are the ones where decision-making capability is distributed among all or most of the stakeholders or participants of the network. Power or authority are upheld by network users. The flow of communication in centralized system is top to bottom, meaning the consumer, like you, who is at the end of the communication line gets to see the minimum of the information. But on the other hand, the flow of communication in the decentralized system is more open and free as the users or stakeholders on the networks are considered equal. Remember peer-to-peer connections while we covered the definition of blockchain. Authority in centralized systems, as covered above, is centrally controlled, whereas in a decentralized system, it is consensus driven. Implementation of centralized systems suits smaller organizations, whereas the decentralized systems are apt for large multinationals and consortiums, meaning multiple organizations coming together under one umbrella. By default, they're good for small organizations too.